I heard that you guys had an AP Physics 1 exam recently, so here are my top 5 AP Physics 1 equations. At number 5, I have v final squared equals v initial squared plus 2 times acceleration times delta x. I really liked kinematics when I learned about them for the first time, and I thought all the equations were really cool, so I could see any one of them being in this number 5 spot, honestly. At number 4, we have gravitational potential energy equals mass times g times delta y. It's just such a simple equation to use, and in this problem, we can use it to calculate that this man standing on top of a 10-meter cliff has 6,000 joules of gravitational potential energy relative to the ground. At number 3, I had to include Newton's second law of motion, F equals mass times acceleration. It's just such a fundamental equation, and you see this in so many problems, not only in AP Physics 1, but also in AP Physics 2. At number 2, I have A1 times V1 equals A2 times V2, where A is the cross-sectional area of a pipe and V is the velocity of a fluid moving in that pipe. I was shocked to see this at first, honestly, because when I took AP Physics 1, fluids was not part of the curriculum, and it was in AP Physics 2 instead, but I guess it's in AP Physics 1 now. At the honorable mention spot, I have the Bernoulli equation. It's a really cool equation, and if you know how to use it, it really makes you look smart. But the reason I didn't place it any higher was because if you wanted to do a computation with this problem, you have to put so many numbers in for each of the variables, and at that point it just turns into kind of a plug and chug type of problem with too many numbers. At number 1, I have kinetic energy is equal to 1/2 times mass times velocity squared. I really love being able to combine this equation with gravitational potential energy, such as in this problem here. In this problem, we're dropping a ball from rest from a height of 5 meters, and we can calculate how fast it will be when it hits the ground, not by using kinematics, but by using simple energy conservation. Isn't that neat?